Hello Natroners, and welcome back to another episode of VFX with Natron. So, today's an interesting day. It's been a tricky day because I had done a post. In fact, let me just show that today's goal is going to be this thing called Metaform Deformation, and it works in a different way, and I'm just looking for... oh, there it is. So this is today's goal. Alright, and as you can see, it's weird. Now what we're gonna make isn't quite like that. So right, let's get over to Natron. And we're alright, so we've used iDistort before to make a bunch of things. And when I originally came up with this concept, or started having this show up for me, it was a project had malfunctioned and made that, and I have no idea exactly why it did it per se at the time. But I found something, so I spent some time trying to recreate something that created something like that, and I found something that works very, very similar, but it doesn't use the original iDeform, although I thought I had gotten something that was... anyway, I don't want to get into it. There's two types of things. We've dealt with iDistort, and iDistort, if we pop an iDistort node in here, and we hook it up, and we connect a source of, let's put in a checkerboard, alright, because it's really good for showing distortion. We plop it in, and as we know, we don't see anything because we don't have anything plugged into the UV map. So we create a solid, and when we put the solid into the UV map, lo and behold, we get something. Why? Because the solid has given it a basically nothing to work with. The iDistort set by default to work off of a UV of 00, which means that it's offset because it's black, and the solid is by default black. It starts off perfectly mapped out. Now, of course, when we start working with it, we've always set it to 0.5 and 0.5. And the other thing we've done is we've set the scale to 100 for the most part. Now, obviously, as soon as I did that, it offset the pattern, because we've said that it's offset by default, and so it's moving towards whatever the color is, which happens to be black, as we can see here. So to fix that, we would obviously have to offset that to 0.5 if we wanted it to remain neutral. So when we look at the original and look at the deformation, the deformation and the original, we wind up getting the same thing when we have a gray. All right, so that's how iDistort distorts. But if we put in an STMap, it doesn't work the same way, and you can see that it, like iDistort, it has both a source, which if we plug the source in here and plug it in, we get nothing. And if we look at it, it also has UV offsets and all this other stuff. So we think, aha, well, all we got to do is set the UV offsets to 0.5, like so. And then we plug that into here, and no, that didn't work. And the reason is actually STMap works differently. STMap does not work off the concept of grayscale. It works at a little bit lower level. Basically, iDistort, what it's doing is it's applying a UV map to a pre-made UV map to that entire grayscale image. So you work from this sort of starting point of gray. Whereas with STM, you don't start with gray, you start with UV. Or technically, it's not UV in the case of STM, it's ST, which is actually a texture map coordinate system. ST is, unlike UV, UV is actually short for the UV coordinates of the UVW texture mapping system. ST is actually a two-dimensional system for two-dimensional map coordinates. All right, and so it's very much like UV, but it is it doesn't have a W. It is no depth to it. It just is positional data based off of a color. It basically, in order to map this source in, we have to give every single pixel on our entire image a color coordinate that is based off of basically what is the equivalent of UV when we see the UV thing. So the way we've made the UV in the past is we've created an STEXPR. STEXPR. We'll just do a regular one. And when we connect that up here, we see that by default, when we connect that up, we wind up with yellow. And you say to yourself, why is it yellow? And the reason is that well, that's because it's actually getting the yellow here. It's a long story, actually. I don't want to... you gotta. We're currently set to have the offset set to 0.5 for the STMap, and if we were to look at this, 0.5 on this is the dead center, and what color happens to be at the dead center of it? Yellow. So when we tell this entire map is set to black, because that's what our STEXPR node is generating. And so it's just picking that one color and filling the entire thing with that one color. All right. So if we, and just for the sake of argument, if we take this node, if we put it down to 0, 0 here, why did that not give us? Wait a minute, let me make sure. Well, it should have given us... Well, that is a bit weird. That should have, I would have thought, given us something. We can see that as we go through it. Aha! Apparently it sees it as 1. Alright, well, it doesn't matter. So... let's go back to our STEXPR node, and let's put in here, to create UVs, we have to create a vector. And I haven't really talked, I don't know if I've talked about what a vector is. Basically, vectors are a container of 3 values. All right, if you have a value that goes from, if it being a floating point value, it goes between 0 and 1 and beyond in each direction. But for color purposes, it's typically 0 to 1. All right, and there can be a near infinite amount of numbers, actually, yeah, near infinite, it could be infinite, between 0 and 1, based off of whatever your system is. Anyway, what a vector is it's some form of container that holds a series of variables, in our case, floating point variables. Now, our colors are obviously... three things. You have R, G, and B. So our R is obviously going to be U in this case. Our G is going to be V, and then our blue is going to be, we want it to be 0 so that we don't, and then we close that little container. And when we do that, the other thing we don't have here is we don't have an alpha channel, so we got to give it an alpha channel of 1. And as soon as we do that, we wind up with what equates to our checkerboard, but it's offset. And the reason it's offset is because we offset our UVs here. So it's taken the entire UV map and it's pushed it off so that 0, 0 on the UV map. So with STMaps, we're going to actually set this back to 0 and set this back to 0. And when we do that, what we wind up with is, this is our UV map. Okay, so these are the colors that make up the coordinates of the STMap. And as we traverse on the U direction, which is the red, from black to red, we wind up going horizontally across the map, or horizontally across our image. And as we go up into green and add the green into it, it goes up on this and gets the coordinates of that. So that's how it creates it. It creates this coordinate, and then so that would be that's the equivalent of gray on an iDistort for an STMap is a UV, just a raw pure UV system. And we can see if we go back and forth between the checkerboard and the STMap, indeed it matches up 100%. And by the way, I do want to point one thing out. This is a no-no. In the community plugins, you might notice, I'm going to just go here. I'm going to go up further up here. Community plugins. If we go down to these relight plugins, there's this thing called the UV map generator. This is not a UV map. I don't know what it looks kind of like a UV map. In fact, here, let me pull it up just temporarily and you can see it. This is what it says is a UV map, and that is not a UV map, even though it was made using an SE-EXPR node. As we can see, the two look very, very different. And if we were to pipe this UV map into STMap, we can see, first of all, it doesn't have an alpha, or it's set to black. So we'd have to put, because it doesn't have the ability to enable that, we'd have to put in a shuffle node. I just want to show how this one looks. So we'll set that to 1, and we can see when we do that, that is not the same as that, which goes to show that that is not a UV map. Whoever made this, sorry to say, but that's a very bad UV map. All right, don't ever use that. If you want to make a UV map, just make a UV map using the SE-EXPR node. All right. So this is a pure UV map right here. All right. And we know it's pure because when this takes UV, and when we get the UV and we get our texture coordinates, we wind up with a perfect identical thing. All right. So I've dwelled on that too long. What are we going to do with this? Why do we need to have that? Well, because this forms the foundation like our solid over here, we need that as our base to merge with things. So what we're going to do is put a merge off of this, and everything that works off of this is going to basically, all the stuff we're going to put over it is going to merge on top of that. And remember, unlike with the iDistort, where if in certain circumstances you can just put an add node at the end, when you're dealing with things that actually have color, you can't add to the color, because otherwise, if we put an add node or after this, it would change everything, and then our whole coordinate system would get messed up. So we need to merge things on top of it, which is why we use a merge over or something, and we have the SE-EXPR UV coordinates as our bottom, or the B input on the merge node. All right. So the next thing we need is obviously, well, we need actually another SE-EXPR to be driven as a metaform object. All right. So let me think. I want to might as well just duplicate this because I already have it. So this will be our metaform input, and we'll put that over it like so. And we put that in there, and it looks exact same as the other one because it's just layering it on top of it, and it doesn't have the coordinate system for what we want our metaform to be. And also we need to make something to drive this particular one, and like in the past, we'll use a radial. And what I'm going to do is I have a nice little radial already pre-made over in my other project, and we'll just, whoops, I may just, did I not, hold on. Copy that one, paste it over here. Sorry, I hit the wrong keys. So used to cloning things in given objects and stuff that I sometimes hit the wrong keys. Anyway, just so we look at it, so we know what it is. This is going to be this object, all right? And so this is going to feed the input number 1 here, and as we know, that's going to wind up automatically shrinking when we put an input into this UV coordinate system here for this SEEXPR, it automatically will take the ROD, it will shift it from the world space or the scene, which we know the scene if we hit S to pull up our scene, project settings. We see it's HD or it's set to HD. Well, we want it to be the shape of this radial, so all we do is we put that into input number 1, and lo and behold, the whole UV project or UV distort shrinks down into this little bitty spice, and we wind up with this. Now, we're going to be doing kind of what we've been doing in the past with in the past few projects with the iDistort node, and when we were dealing with putting the coordinates in, we're basically going to be changing this so that instead of being UV, what we're going to do is do 1 minus U and 1 minus V to start off with. And we're also going to tell it that we want to obviously get the, we want to have our, let's just for a minute go over to our alpha channel. Our alpha channel right now is set to 1. We want it to be the alpha of the input 1 source, so all we have to do is say AS, and when I return or click out of that, we can see that it changes our alpha channel to that. But of course, when we go back out of the alpha, we see that it didn't apply it because it hasn't multiplied it. And in the past, I multiplied it per channel. I'm going to show you a little trick. This I don't like doing this normally, but it's another way of doing this. We could multiply this entire color. This whole unit here is actually a color, and if we multiply the whole thing times the alpha, so if we say AS times this, it will also do the same thing. The only thing is it's also going to multiply against the our blue channel, which means it's going to actually, no, it did do it right. Never mind, that works. There are times when we do certain things. Oh, yes, I know what it is. Right, what it is we could have also multiplied our -1 against this. That's what I was thinking. You'll notice I put the -1s in there. We could technically do the just to show you, I want to just show that that works as well. We could say 1 minus, and then instead of doing the U and we could have just left it at U and V here. We could have done that. This also works, but what it does is it inverts that's the exact same thing. The only difference is now it's subtracting the blue channel. So when you go negative, it actually inverts it, so it winds up being positive for UV maps, which sounds weird, but it's a good thing, believe me. And the way you'd fix it is just to shift that to 1. So we could just do that, and we wind up with the same thing. That's actually an inverted UV. And then we could take this whole thing and multiply it times AS. I'm just showing you a couple things. No, we can't, because it needs to process multiplication happens before addition, subtraction. So we have to put those in parentheses. Anyway, that all works. There are all ways of getting the same thing. Doesn't matter. However you get here. So I just wanted to pull that up. So this is our coordinates. I just want to make sure that I've got everything where I want. Looking at my source, this is fine. All right. So we've got this going into our thing. We go to over here. We've got this, and we can see over here that now what we've done is we've taken and put this sort of this UV map over UV map. So we're reapplying it. And when we go down to the STM, we wind up with this really funkiness down here. Now, if I'm not mistaken, right, what we want to do here, to get Metaform to work, we have to change a couple things. First thing we want to do is we want to disable the B channel's alpha channel, because we don't want this back. I mean, you could have the background in there, but, well, all right. Yeah, we'll leave it on for right now. What we're going to do is set this to exclusion. When we do the exclusion, yeah, it's not working right. It doesn't look right at all here. Let's just go to here. And now, I get a different result. That looks a little different than I got last time. By gum, I think it's doing it again. Hold on one sec. Let me just verify in my original project that this looks the same at this value. I'll be upset if I got another project that's wonking out on me. That's 1-1. Alright, that's good. Good. Oh, don't do this. I tested this twice on another thing and it worked fine. Alright, hold on. Let me just look here. Alright, that looks correct. Let's make sure we've got the same thing here. That looks correct there. That looks correct, but in a different spot there. That looks right there. Hold on. No, that's right. All right, this is a metaform. All right. So you said to yourself, all right, we can see as I move it around, I get this, it starts trailing around doing this really funky thing, and it just didn't look quite right to me. Sorry. And as we increase, as we increase or decrease the value in here, you can see it distorts it a bit more. So how the metaforms work, this is the thing that's kind of weird and cool about them. This is basically a metaform object right here. And all we have to do to create a new metaform object is copy this over and then take it, let's put this, I'm going to put this down here so it's out of the way of my additional A inputs. So let's put this one over here. This is going to be our second metaform object, and we take A2, put it in here, and then right now they're on top of one another, but if we put it off to the side, we can see that we get this, they start interacting with one another in a really interesting kind of cool way. And I think the one difference I did in the original one was I think I set this to 0 and set the center width to 0 so that I wound up with something more along the lines of this when I did it. And I also I am getting I'm going to let you know this is a slightly different distortion values than I was getting before, but I believe if we were to adjust some settings, you could easily, and play with our input values, you could get it. And so this winds up doing the whole metaform deformation thing. But the reason I wanted to use exclusion, this is really kind of neat, is that there's another cool property I liked when I was playing with this and got the exclusion, is as they add together and get on top of one another, they actually start subtracting, and you can get this like donut-y form towards the center here, which is kind of neat. It creates this really weird distortion in the center, a kind of a void. So anyway, you don't have to use exclusion. I think you can. I was able to get it to work with both plus, which actually plus didn't work so well. If the values are too high, it made the plus look weird. So we need to bring this down to 0.5, I believe it was. And then we need to bring, this value down to 0.5 as well. Well, that one's pushed. It's pushed past the edge of the map. What we can do is, if it starts doing this type of thing, I believe, where was it? We can turn off the black outside on the STMap, and you can see that fixes the problem. And basically what it does is it starts repeating the pattern beyond it, so it's just a continuous pattern forever. And so you can wind up with these really interesting kind of cool meta objects that just kind of you can bobble around with and stuff. And the other thing is that what was it? Right, there is a problem that dropped the value of that. Right, that's not as well. It's you know, you can play with it and have fun, and it's not a very complex thing. Well, I think that's pretty much all there is. We can take other types of metaform or objects and plug them in. What I did in the original animation was I took something like this and I put in a roto node. So I put in, set tab, roto, I might actually have to pull up my original because I don't remember all the bits. But I was talking with Mr. Thomas Morley in a chat about this, and what he was wondering is what it would look like if we put just a random shape. So what I did is I just made, I don't know, I just did something like this, then that, and then like that. Actually, I think I did that, and then I did that, and then I did, and then I did something like that, and then back to the original. And I wound up with something sort of like this, and then I like pulled it around a wee bit, and so I wound up with something like this. And then, as we all know, that if we set this to be all, we need to set this so that it's 1. And the problem is that, of course, roto nodes don't have actual alpha in their thing, although they do output alpha. So what we have to do is we have to, I believe it was, I'm just really trying to remember how I did this. I think what I did is I first blurred it, because the problem is that if you can pull the edge out and but you wind up with the plateau effect, which doesn't look as nice. So to get it to sort of look softer, what we want to do is blur it. So we just sit here and we type in, all right, I was in the wrong area. I was over the view tab here. There we go. Let's put a blur. And we can take the blur way up, because it's going to require a lot of blur to get this thing blurry and soft. That's probably in the neighborhood of where we could deal with it. And then what we have to do is add in a shuffle node. And so now all we really need to do for the shuffle node is make it so that the alpha is from the red channel. Just copy it so that when we go to the alpha, we see that it's the same thing. And then all we really need at this point is to tell it that we want to, we need to put a multiplier like we did yesterday or on Saturday. So if we instead of driving the roto, you could drive the roto's color, but it's just easier in this case to drive everything with a multiplier. So we'll just put in it tab. Why didn't that work? Tab, try that again. There we go. Get our multiply node here. And as we can see, we can take our multiply, and as we increase our multiply, that increases the value. And so then all we got to do is take one of these meta distorts. Let's clone it over here. Put the meta distort creator into this, into one of the inputs. Take the output or input number 1 from that, plug it into the shuffle node. That should automatically put UV coordinates on there. And when we go over here, we can see they're all combined together, and because it's set to plus, they're adding together. And now we wind up with this really funkiness. And oh yes, there was one other thing that I did. I believe I took this entire thing. Whoops, I just disconnected it. And I'll put, because it's a pain in the butt you can't really drag around the roto very easily. So what I did is I put a transform node after the shuffle node. So we'll hit T, put in a transform, and just grab that transform, and you can pull it around, and now you have a mobile object of whatever shape you want, and you just modify, and it interacts like whatever, and then you can animate your roto node's shape to recreate do whatever you want, and you just animate those over time. So if we go to 0, for example, let's grab our original sphere over here. Now, mind you, these don't have motion blur attached. If you want to do motion blur, actually, I don't know how motion blur would work with this, because it's I would avoid motion blur on this. I don't know, experiment, play with it. I'm just thinking, you're going to be motion blurring UV offset. It might work. You might create some funkiness. You might wind up with these really interesting distorted trails coming off of it. I didn't want to take the time to actually experiment with it at this point, but it's worth playing with. Anyway, let's add some animation. Right, we want to go here. Let's take all we have to do because we're only dealing with the position of this. Let's just add set a key, all dimensions for this. Let's go over to our other radio. Double click on that. Set a key here for all dimensions. Pull that somewhere else more interesting, like down here, and let's take our transform node for the roto and put it, or the transform on the roto. Set a key there. All right, so these are our animation nodes, so let's get those isolated. I like getting them so they're nice and easy, so I'm not going to get distracted from them. Those are the three things. Let's go ahead in time. I don't know, we'll say 24 frames. We'll do it in increments. Get out 24 frames. Grab this one, sort of pull it over here. Grab this one. Pull it up so it's interacting, like so. Probably like that. We'll have it do a swirly around it for a second. We'll go over here. We'll pull it around like that. And at the same time, we'll take the other one and we'll pull it sort of around, sort of with it. So there's movement there. And then we'll just go ahead another 24 frames. Sort of pull this off like that. Grab the second one, pull it down like that, pull the other one, all right, it's right here, pull this. Now we're going to want that to start. All right, I want to go back here, set a keyframe here because I don't want it to start moving into there until that point in time. Pull that in, and why is that not drawing? That's odd. Alright, let's not do black outside. Maybe. Why is Natron... This is the same problem we ran into with the stupid... Oh, alright, Natron. Why are you doing that? You know what it may be? Oh... It could very well be because the roto isn't actually an official object. Alright, let's try this. Oops. Let's put let's merge the roto over a constant just to give it a true shape. Let's put a constant. Alright, let's take a constant. We're going to make a constant. It's going to be driven by the roto originally, but that's going to create a problem there. Alright, I need to make my constant. Let's pull this. Let's go back. Oh, boy. It's still not going to draw because the constant's not... Well, let's see. Let's go back to frame 1. Let's pull this. Where is that? That's weird. Why don't I even have... There it is. Let's pull that back in. Alright, it's drawing there. Now let's just, sorry, we're going to just make this a size. So we're going to reshape it so that it's that big by about that big, by about that big, by about that big. I don't know if that's accurate or not. Let's just pull this in so we can see the shuffle node, or the constant. Yeah, that ought to be more than enough for, just keep it a little bit bigger. All right, so there we go. All right, let's try and pull that off and see if pulling that, whoops, I didn't want to do that. Alright, let's back that up. There we go. Grab our transform. Let's pull that. See if that pulling that off. Now let's go forward in time. Forward in time, and it's still not working. All right, why? Well, I can't tell you why that's not working at this point. It's clearly in Natron's not drawing outside the area outside. It should, because we haven't told it to clamp it. We haven't told it. I don't think anything in here doesn't allow it to. There's probably something in here that isn't set to expand the ROD in some form. No, expand. Oh, crop to format, maybe. There we go. Try removing that there. All right, that should maybe. Oh, there we go. All right, it's glitching a little bit. It's just that's a cache issue. All right, there we go. That was what it was. Let's clear our caches. Clear all caches. Now it should, when we go forward in time, it should draw it fresh for the first time. Alright, it's still not doing it. Just know that's a cache issue. Natron's just being persnickety. Let's try and force it to do a full refresh of the of a frame. Alright, let's find the frame. That's the frame it's giving us issues on. There we go. Cache. Clear all caches. Let's go over here. Let's go over here. Alright, let's see. Nope. Whatever. It's just glitched out there, but we see it does work. So just disable it before you start animating it, and it should probably function. So anyway, you could see you could just do an animation, and the ultimate thing is that we wind up with something that sort of does this, and it moves pretty quick, as you can see. And you can change. Obviously, we didn't finish it, or we're not finishing it, but you can change this from plus to screen, or there you go. Screen is probably what I used on the original one. That looks a lot more like what I remember it looking like. Anyway, there we go. Metaform objects, pretty neat. They're really kind of like 2D metaballs. And it also gave us an introduction to the STMap. And we're going to actually be doing more with STM in the future, and talking about it, because a lot of the stuff we did with our Distort, if we took those same types of things and started doing it with STM maps, we'd wind up with very different results. And, merging it, obviously we couldn't do it exactly the same way, but a lot of the stuff works the same way. It works. Obviously the UV system, we have to give it the UV system in the same fashion. Well, actually we don't. We could feed him anyway. We could either feed a color over this, which would give it a specific color, and then you'd wind up with a solid colored mass that goes across, which wouldn't be very interesting. Far more interesting is when you start dealing with these sort of UVs. It actually will, what it would do is it would pick whatever it is and just transform it across whatever is already there. So it would look like you're taking something and transforming it across it with a texture and transforming it across, which could be useful. Anyway. And it is useful in some ways, because I can show you, I'm going to show things about that. We're going to be tricking it. It actually becomes, I'm just looking at the time. I don't want to go past, I don't want this to go more than 45 minutes. One of the cool things is that it can, you can use it for faking 3D. Think about that. All right, we're done. So, right. Again, so today's goal was to make basically this, or something like this. And you saw that's just animating of what we saw. And so that's it. Thanks for watching, and until next time, keep on Natroning.